let's get started. Thank you all for joining. We will talk a little bit in the next round, 40-45 minutes, about how you can get the most out of virtual threads in Java 25. Short introduction to myself. My name is Christian. I've been working as a software engineer for like the last 16 years. Started with Java 5, and then like 9 years ago, I switched over to more of a full stack role. Since then, I'm also heavily working in the front-end area with TypeScript, JavaScript, and Angular. Now, I'm also a Microsoft MVP for web dev and developer tools, Oracle ACE in Java, and I also do like trainings for like Agentic AI, Java, Kotlin, TypeScript, and Angular. And I also really enjoy doing like conference talks like this one here at Spring.io. And in my spare time, I also on YouTube, so I also do like content creation about TypeScript. So if you want to get in touch with me or get any information also about this talk, just visit my website, type.rocks. There you find my LinkedIn, GitHub, and also my YouTube channel. So if you have questions, just a quick reminder, there is the app for the conference where you can submit your question for the current talk, and then we will go through them at the end of the talk, or of course you can ask them just later. The topics we will talk about today is, we will first do a brief introduction about virtual threads. I will not go really into detail because this takes some time, but then we will go over how StructuredTaskScopes work, so how we can use concurrency to run like virtual threads in parallel, and also how ScopedValues work, like how you can remove ThreadLocals and change them to ScopedValues. This will be especially necessary for StructuredTaskScopes. Short introduction to virtual threads. If you want to have a more in-depth video about this, you can go to type.rocks/VT. This will redirect you to a YouTube video from a talk of the conference of DevOps. So this will then show you in detail how virtual threads work. Now, what is the issue with normal threads? Why didn't they work? Why couldn't we use like normal threads before, and why did we switch over to reactive programming? This was mostly because when you create a normal Java thread, it always will create a thread on the operating system. And this is why we have stuff like thread pools, because when you create a normal Java thread, this costs between 1 to 2 megabytes of memory and is quite expensive to do. So this is why we couldn't have like an unlimited amount of normal threads. Now, with virtual threads, this is completely different, because virtual threads only live in the JVM. There is no thread created on the operating system, because this only lives in the JVM, and because of that, it's like 1,000 times cheaper. So, for example, this costs only like 1 or 2 kilobytes to create such a virtual thread. Now, how does a virtual thread work? Now, of course, a virtual thread doesn't have a corresponding operating system thread. So to work, it needs a so-called worker thread. Now, a worker thread is just a normal thread like you know, and when a virtual thread has to do some work, it looks in a pool of workers, connects itself to it, and as soon as it finds one, it uses it to do the job on the operating system. Now, the cool thing is, let's say you have a normal web application. When an endpoint is accessed from a user, a virtual thread will get created. It looks for an available worker, connects itself, but as soon as it blocks, for example, as it's waiting for another REST call it's making, or for database, or for some network, it will unattach itself from the worker and will then have the worker thread available for other tasks. This means that we can have like a really small amount of worker threads and a huge amount of virtual threads working on them. So for example, you could have like 1 million virtual threads, and when you only do like really small stuff on the CPU, you only need like 40 worker threads. Now, as soon as the operating system tells the virtual thread that it's now done, for example, the response of a REST call is ready, it will then tell this to the virtual thread. The virtual thread will look around for an existing worker, connects itself again to it, and will continue its work. So we can see here, this isn't the same worker thread as before, because this doesn't matter. It doesn't have to be the same worker. For us as developers, we don't have to care which worker thread is used, because this is just like underlying architecture. We are only working on the virtual thread. Now, between Java 21, when virtual threads were released, and Java 25, there were some huge improvements about performance. So let me show you what this means. Let's switch over to IntelliJ here. And I have here a small thread test. And what we are doing here is really simple. We just create 100 virtual threads, and then we say when we start this thread, it should just run in a synchronized block a thread sleep and then print the current thread. Now let's see what happens, because we would think that, well, okay, this is only 100 virtual threads, we have this thread sleep which blocks, so our virtual thread should be disconnected from the worker. Let's see what happens here when I run this. We will see that this will take 10 seconds. Now why is the case? Because the virtual threads are pinned to the worker. Because in Java 21, this was an issue with the virtual threads. When you were inside of a synchronized block, you could not disconnect the virtual thread from the worker thread. So you can see this took 10 seconds. So let me now show you what changed with Java 25. So I will change here from Java 21 to Java 25. And I will also update my POM XML to Java 25. And let's make sure that this is actually using Java 25. Yeah, it is. So when I now rerun the test, we will see that this no longer takes 10 seconds, but this takes 1 second. Because now they no longer block and pin the worker on the virtual thread. So they changed that with Java 24. Now, if you still are on Java 21, because we know, like in larger companies, it's really hard to upgrade that fast. You can still benefit from virtual threads, and of course, only care about this when you're doing like heavy stuff in synchronized. You most likely will not have a thread sleep in a synchronized block. But when you have it, you can use a so-called reentrant lock instead of synchronized. This is, for example, what Apache Tomcat did when they switched to virtual threads in Java 21. They had the same issue, and they switched their synchronized blocks to reentrant locks, and this solved like 90% of their issues. So this is just a quick introduction what changed. So basically, the issue was that all virtual threads, 10 virtual threads were pinned on the workers, and because the thread pool of the worker threads only is like 10 threads, this will then block all these worker threads until this 1 second is done. Now, let's build a real app and let's see how we can use virtual threads for that. So let's switch over here to our Spring Boot application, and in here, let's go into our Spring Boot app here. We can see here this is a simple Spring Boot application with version 4.05, but you can also do this with 3.5. So let's create a new main controller here. And what we will do here is we will create a simple REST controller which has request mapping behind API, and we will have a really simple get mapping where we say we want to have the information of a speaker, so the talk from him, and we will have the talk here, and we have a get talk where we have our path variable like this. And now what will this talk be? This is something really simple. We just say this will be a record which is a wrapper around the name of a talk. And of course we could now just return the talk. But of course what normally happens is we call a database or we call a REST endpoint. Now of course we could create just a normal REST client and then use it against a real API. But to have like a reproducible example, what I will do is I will do just like a really simple auto-wired private fake REST client here. And what this fake REST client will be, this will just be a really simple service which will work as like a REST client for us. Now in here, we will keep this simple. We just say return fake REST client, retrieve talk, and we pass in our speaker. Now what does this retrieve talk do? Of course, this returns a talk, and we say talk for speaker, and we have our speaker in here. Now we will add a thread sleep in here of 1 second. So what now will happen is, as soon as a request enters our endpoint, it will take a thread from the thread pool, and then as soon as these 200 threads are occupied, the other threads have to wait, because currently we are not using virtual threads in this application. So let me show you what this means performance-wise. Let me start the Spring Boot application, and let me switch over to JMeter, where we will call this API talk and then the speaker name. And we will then measure how long it will take for one response to finish, and I will run this with 1,000 concurrent user. So when we now run this, we will see that because we start to measure only after the first 10 seconds, that even the first request will take like 2 seconds or even more, because the threads are already blocked and there are no more threads in the thread pool. Because Tomcat normally has like 200 threads defined in the thread pool, so it's not working for the other ones. We can see here 20 seconds have passed. Let's now see the graph, and we can see it's like maybe a little bit small in the back, but it starts at 2 seconds and it goes up to like almost 5 seconds, which it takes for the last request to finish. Now let's fix that. We can just go back into our application here, and we go in our application properties file and we enable virtual threads. Now let's just restart the application without doing anything else, and let's rerun this test. Let's clean this up here and rerun this. Now what will happen? Because we enabled virtual threads, the executor service in Spring Boot is no longer using the thread pool executor service, but it will create a new virtual thread per task. So each request will get its own virtual thread. It will look for an available worker, connects itself, does the work, and as soon as it blocks, in our case because of a thread sleep, normally because it waits for a response of the REST client, it will remove itself, and so the worker is now available. And because this takes just a really small amount of time on the CPU, most of the time will be done blocking, so this means every request now takes 1 second, like without changing anything, without rewriting anything in reactive or project reactor. You can just enable that and maybe we'll have a huge speed improvement. Now, of course, this is not how a normal application looks like, because normally we have some more stuff we do on our endpoints. Maybe we gather some information from other resources and then we return it back like as a single object to the user. So let's do that. Let's say we have here our get mapping, and we still say we have /speaker like this, and we have a speaker object which we return, and let's call this get speaker, again with the path variable of speaker. And what we will do in here is, this speaker will be a wrapper around 2 different objects. The first one, of course, will be our talk, so we return the talk, and the second one will be our info object. Now, what is this info object? This will just contain a list of strings, and we have our info list here. Now, what this is, we will just gather information from our talk and from 3 different sources to get information about the speaker. Now we want to have the resource with the most information about the speaker. So how do we achieve this? We say first we have a talk here, and we call, of course, our retrieve talk with the speaker. And then we also say we have our infos Google, for example, where we say retrieve infos Google, and we pass in our speaker. Now what does this do? This is basically doing similar stuff as before. We return an info object, and we return here info with a list, and we say, of course, always the speaker is in there, and we have also, let's say, my birth date. Now, what we also will do is, we will say we have a thread sleep of 500 milliseconds. Now, this will be, of course, shorter than like this retrieve talk. Maybe the request will be faster. Now, let's copy this and do this 2 more times. And one will be for, let's say here, LinkedIn. And LinkedIn knows maybe a little bit more about me, so I will say add also full stack in here. And we will also have stuff from Facebook. But the Facebook thing will be different, because we can here say throw new runtime exception, no account found. Now let's use this in our main controller, right? So let's copy this 2 times. And let's just say this is for Facebook here, and this here will be done for LinkedIn, like this. Now, we want to gather these 3 streams and into a stream, and then figure out which one has the most information. So we have our final war best infos here, have a stream of infos Google, infos Facebook, and infos LinkedIn. And we'll make this really simple. We'll just say we have a comparator where we say take my info.info list and take the size of it, and the one with the most information, we will take that one. And we will then return it. We say we have our talk and our best infos. Now this looks fine and looks really easy, but the issue with this approach is that this is really slow, because let's clean this up a little bit first. So we will take this one here and let's put this in its own function, call this getInfos. And the issue with this is now that talk here takes 1 second, and if everything goes fine, this takes 3 times 500 milliseconds. So all in all, this will take 2.5 seconds until it is returned to the user. Now we have another issue with this, because here Facebook will throw an exception, so our whole request will fail. So different ways of solving that. The first one would be to use like reactive. But why shouldn't we use reactive in this case? Because first thing is, virtual threads were basically invented to so that we no longer have to use reactive. And also, when we are using it like this, reactive code would look basically like this. This is now done with completable futures, but it's basically similar with other reactive frameworks like Project Reactor. And so the first thing we would need to do is like make everything asynchronous. We would need to replace like the REST client with web client, make our database driver, use like an R2DBC driver. Also, all our functions need now to be able to work with this asynchronous library we are using. And this is quite a huge amount of boilerplate code. Also, it makes it hard to test. So in my opinion, we shouldn't really use that. What we can use, on the other hand, is structured concurrency. Now, structured concurrency is in its final preview now, and it will most likely be released in Java 27. So if you want to use it like this, you would have to use like the experimental feature flag. Now, they basically, when I went from Java 21 to Java 24 and showed this talk, nothing really changed, right? They didn't change anything in the API. With Java 25, they changed everything regarding this API. So the complete API changed, also the handling of this stuff. So everything you see now is only working with Java 25 and Java 26. Before, this would no longer work because the API is completely different. Now, let me show you what we can do with this. So, what is a structured task scope? Basically, a structured task scope is nothing else than like a fancy executor service. So you can create a new structured task scope and give it a task, and it will run this task in its own virtual thread. So how do we create one? First, let's clean this up here. And now let's say we have a try with resources block, where we say StructuredTaskScope.open. And with this, we create a new structured task scope. Now, we can use this scope and pass it our calls as a Lambda function. So we can say scope.fork, and we can see here, this takes a runnable or a callable, and it returns a subtask. A subtask is similar to a future, and it can have 3 different states. The first state is success. This means that the call which you did ended successfully, and you can use .get to get the result. Failed means you can use .exception to get the stack trace you get from it, and unavailable means it's still ongoing. So how can we now do this? We just wrap our fake REST client calls into our scope fork, like this. And now, of course, we no longer get back an immediate result. We now only get back a subtask of type info. So because of that, we can no longer just stream over the results. What we need to do is now, we need to tell Java that we need, at a certain point, want to wait until all of these tasks are finished. So we start these different subtasks in our own virtual thread, and then we want, at a certain point, gather the results from them. So how can we achieve this? We just say here scope.join, and because of that, we are then waiting at this point until all of them are done. So let me just throw these exceptions. And now, because we know after this line here, we can now access the result, we can now do some filtering. So we can say we have a filter where we say task.state equals state success. In this case, we will then only have the successful ones, and we will then use map here, and we say subtask.get to get the results. Now, this worked perfectly fine before Java 25. Now, including Java 25, this will no longer work because it will throw an error immediately because of this retrieve infos Facebook. Before, you could gather the information yourself, and then the default behavior was that then you only have to filter the failed ones yourself manually. Nowadays, when you're using open, we can see that if any subtask fails, a failed exception will be thrown. Because of that we can still have the behavior where we can gather the information ourselves, we need to use a so-called joiner. A joiner is like a custom configuration how you want to handle any subtasks. Like if they are failed or successful, you can handle them yourself. Now, there are already implemented ones from Java, for example, await all, which is exactly what we want to use here, because this will make sure that it waits for all the subtasks to finish, so that we don't have to care about each individual response and have like a try-catch. Now, this would work perfectly fine, but we could make this even faster because talk and best infos here also are not dependent on each other, so we can also add a try with resources block there. Say we have our open here, where we create a new structured task scope, and then we basically do the same. We say, I want to create a new virtual thread for my retrieve talk call, and I want to do the same for my get info. So we have here our call like this. And now the only thing we need to do is we need to use scope.join, and then we can call talk.get and bestinfos.get. Now, as you can see here, I'm not using a custom joiner because I want these two to finish successfully, or otherwise the whole request should fail, because I need these two to return to the user. Of course, I could also handle the await all, and then could handle if there is no result in best infos, and then just return like an empty list, but in this case, I will leave it like that. Now, before we try how this works, we will clean this up a little bit, because we can see here there is a large amount of code inside of this get info block in the controller, and we shouldn't have that much like business logic in there. And this is why we can also create our own joiner and handle the business logic in there and make it reusable. So let me show you how we can achieve this. The first thing we will do is let's create a new Java class, and let's call this info joiner. And we will implement in this info joiner the joiner interface. Now, this joiner interface is really interesting because it takes two generic arguments. The first one is the type we want to allow our scope fork to return. So let's go back in the main controller. What we currently can do is we can, for example, say scope fork, and we can just do like this, because we have no restriction what we want in our scope join, in our scope fork as a result. So let's fix that. In our case, we only want to allow info objects to get back from the scope fork. And the next thing, and this is also something they changed with Java 25, this will be the return type of our join function. So when we go back in the main controller and we check here for join, we can see we get back void, not like the lowercase void, but the uppercase, like the object type void. This means that await all will not return anything. We have to handle all these results ourselves. But we don't want that, because in our case, we want to just return scope join and get back this info object we have done in our joiner. So we have here info and info for our both types. And let's now implement the methods. The first thing is result. Result is the thing which gets called when we call scope join. So we will need that. The next would be onFork. onFork would be the function which gets called when you call scope fork before a virtual thread gets created. So we will not need that in our case. And onComplete, this will get called every time a subtask finished, successfully or failed. And we, of course, need that to handle the results from that. So let's implement these. And let's now see what we can do with that. First thing we will do is we will set a private final collection. And this will be of type info here. We have our result here. And we will use a concurrent linked queue or any concurrent collection, because we are accessing this joiner from different threads, and like array lists are not thread safe, so always you have to use something like that. Now let's copy that and also make a collection for our throwables, and we will store our exceptions in there. Now in our onComplete, we get the subtask here, so we can say we have a subtask.state. And in the case of a successful one, we will say results add, and we can now safely access the .get, because we only have a result when we have a successful state. The same we can also do for failed, because then we can say add subtask.exception, because we only get an exception in a failed task. Of course, we need to do the throwables. And in the default case, this should basically never happen. We can say throw new runtime exception, illegal subtask state. Subtask state. Now, we can see here that we have a Boolean we need to return. What is that? This Boolean indicates if after this onComplete, the scope should be closed or should continue to do its work. Now, in our case, we always want to return false because we want to handle this ourselves with the scope join. Then the scope will be closed. Now, this would be nice, for example, for a fail fast or for a find first, where you only want to have like the first result, gather it, and then you are not interested in the other ones. In our case, we want that. Now, in the result here, we can say, well, if the result is empty, in this case, let's create here a new runtime exception. And we say here we have no data found. And we can do a really cool thing. We can say for each of the throwables, we will add them as a suppressed exception to our runtime exception. So because of that, you then throw this runtime exception with no data found, and you have all the stack traces of the failed requests. So of course, we will now say we throw the new runtime exception. Otherwise, we can just go back in the main controller, and we can take this max or else throw, and we can put it into our info joiner by just saying results.stream, and then we are again doing the same thing. Now, when we look at the code we have here, it's first, in my opinion, it's really easy to understand, and it's also really easy testable, because you don't need to create like a Spring Boot test or anything and access your endpoint. You can just create a normal JUnit test, create a new info joiner, call onComplete several times with subtasks you created, and then check for the result. So you can really test this unit yourself without having to create like a huge Spring Boot test or like a web MVC test. So let's now see how we can use this in our application. Let's switch back here to the main controller, and let's clean this up here. The first thing we will do is we will replace this await all with the info joiner, and now you can see you can no longer call scope fork with anything which does not return info object. So we can remove that. Also, we no longer need this return here, because now when we check what join here returns, we can see we get back the info object from our result function. Also, we can then use return like that, and we also no longer need these assignments, because we no longer need to stream over them. We just need to pass them to the scope. It will return, and we can use the scope join for that. And this is now everything we need to do to have our application run all these tasks concurrently on different virtual threads, and all our business logic is handled in our info joiner. So let's now restart the application, and we will now go back into JMeter. I will switch this from the talk endpoint to the speaker endpoint, and let's clean this up here, and let's rerun this. So what will happen is now, when we go back here in our speaker endpoint, we will enter our system with one virtual thread. This will then create a scope. It will create now two virtual threads, one for the retrieve talk and one for the get info. And in the get info, it will create 3 more virtual threads. And we will then wait for all of them to finish by using scope join, put them back together, and then return it to the user. And because of this worker threads pattern, and because we don't do much work on the CPU, this will be a huge speed improvement. So we can see here we are done. Let's check the graph here, and we can see this still takes like 1 second, because this is the longest request, like this retrieve talk. This takes 1 second. It can't be faster than this blocking we had there. So what did we see now in the structured task scopes? First, we can see how easy it is to create such a subtask or like a structured task scope and then send your request to it. What you also couldn't see, because we didn't have to change anything, is you didn't have to rewrite any of your logic, like any of your calls you made. You didn't have to replace it with a web client. You didn't have to like rewrite your logic to make it asynchronous. You can do this stuff with like legacy Java applications. Also, it's really easy to manage error states. As you can see, you can say I want to fail fast, I want to handle exception myself. You don't really have to do anything like with try catch around it. You can do all this stuff later. Also, it's really easy to extend it. You can basically also create like generic joiner joiner classes, like a collection joiner maybe. You can also really easily do this like for all your business logic and gather it like in one unit of work. And I think the last thing, and this is the most important for me, is like it creates simple, readable, and testable code. Like what you have seen in the info joiner here, you don't have to have basically your own testing library to make your reactive code like synchronous again. And it's also much easier to understand, like for most developers, how synchronous or sequential code works. So this is all really nice, but what you need to do is, what now happens with this approach is you are now no longer using a one thread per request pattern. Like in this case, you have seen we have the info, for example, these info calls, and they are called in 3 different virtual threads. So we need a different pattern maybe if you're working with ThreadLocals. So let me now show you what scoped values are, because scoped values are an alternative to ThreadLocals you can use right now. They are no longer in preview, they are available in Java 25, and they are like a precondition for StructuredTaskScopes. So let's go back in here and let's just create a really simple class here. And this will be a user filter. And in here we will say this will be like configuration. And we will have our implements here, and we will implement the Jakarta servlet, and we will do some really simple stuff. We want to extract a header from our HTTP request. Of course, we could do this differently. This is just like for demo purposes. We say we have our user here, and we have our request, and we have our get header, and we want to get the user header. Now, how would you make this normally available to the application? You could just say, well, I create a public static final thread local, and I have here my thread local like this, and of course I make this a string. And then this makes it really easy to set. We just say user thread local.set user. Now we just call chain.doFilter of our request and our response, and we are all set. Now, before I will show you what's the issue with this, let's also just do the same, but for scoped values. So for scoped values, we'll just copy this, and we say this is a scoped value. And this will not be called user thread local, this will be user scoped value. And we don't say new, we say scoped value dot new instance. Now, when we try to set this value by using user scoped value dot set, we will see that this is not working. Because you can't just use this like a normal thread local, you need to provide a certain scope where you want to make this scoped value available, hence the name scoped value. Now, how can we do this? We say scoped value dot where, and as you can see, where takes a key and a value. So the key here will be the user scoped value, and the value will be our user we extracted from our request. Now, you can see here that IntelliJ tells us, well, you are not using the return value from your where. And because we did this, nothing really happened. We just created a so-called carrier, and this carrier here can now be passed to a certain function, which then has access to this value we set in our scope value. So how can we achieve this? We can just say .run here, and this .run here takes a lambda, and in this lambda, this key value pair will then be available. You can also, of course, use call to get back the result from your function, but in our case, we have the user filter, doFilter, which returns void, so we are using run instead. Now, we will just create a lambda here, and now let's put the doFilter inside of this lambda. Now, what happens is we tell our scope value, we set the user value to this key, and inside of this lambda, when we access user scope value.get, we get this result. Now, let's see if this is working, and let's see what the issue is with the thread local. So let's just go back into the main controller here, and the first thing we'll do is, let's just say here we access our user thread local here, and we will use here .get system out, and then we say this is our main controller thread local, like this, and let's copy this and also do this for the scoped value. We have our user scoped value.get, and we will do the same also in our retrieve talk, and we'll call it like this. This will no longer be main controller, this will be retrieve talk. And let's now restart the application. And we will now send one request with this user header. So I have my generated requests here, where we can say, have my API speaker and then the user header. Now let's run this. And we will see here that we have an interesting response. We get for the main controller, we get for the ThreadLocal and for ScopedValues, we get the hello there. But for retrieve talk ThreadLocal, we don't get the result. Only for the retrieve talk ScopedValue, we get the hello there result. Now, why is this the case? Because ThreadLocal, of course, only makes the value available in the current thread. And when we check our code, we can see here that here the virtual thread, which gets past this user ThreadLocal variable, this is the same thread in here. But here, scope fork creates a new virtual thread, so this retrieve talk isn't the same thread. So this means that the ThreadLocal variable isn't available in there. So this is exactly why we need to use ScopedValues, because ScopedValues are really different to ThreadLocals in different behaviors. The first thing, of course, is ThreadLocals are, as the name implies, per thread. So we only have, when we set it once in a thread, we have it available anywhere in this thread, but not available in other threads. Where ScopedValues have a variable scope. They don't care about threads, they care about like the scope you provide them in. So everything, for example, in the filter chain, everything which is after this filter chain will have access to this user scope value. Also, ThreadLocals are mutable. I could, for example, change the user scope, the user ThreadLocal value anywhere in my code, and it would then be changed for the whole thread. As ScopedValues aren't changed for the whole thread, but you can't even change. You only have to like override them inside of another scope. So what this means is I can go in here and we could maybe say, let's switch over to user filter. When I want to change this in here, I can't just say like user scope value.set. I would have to say I want to override it in this inner scope, and I want to say I provide a new scope value and then use a run in there, but it will not like mutate it, it will only make it available in this inner scope. So you can always be sure which part of your code has which value available. So, and the last thing is also ThreadLocals don't know inheritance. This means that if you don't use like an inheritable ThreadLocal, then you will not have like it passed into child threads, as we have seen here. The thread which was spawned in the other one, in the parent thread, doesn't have this value. Whereas scope values are inherited in child scopes. So for example, when we say here we have our scope value with the user scope value, and I go in here and I say in there I want to have like an admin scope value, then in here, in this inner scope, I would still have access to this user scope value, so to the outer scope. So when should you migrate to these scope values? The first thing, of course, is when you're using structured task scopes with virtual threads, you should always migrate, because when you're using ThreadLocals in there, then it's most likely will not work as expected, because as mentioned, you don't have access to these in your virtual threads to the same ThreadLocal you set somewhere else. There is a really cool property for that, where we can say you can enable JDK trace virtual ThreadLocals, and this will then show you a stack trace every time you try to access a ThreadLocal in a virtual thread, so that you know where you maybe still have issues. Second is also, you can use this even without virtual thread. It isn't like bound to this virtual thread stuff. You can also use it if you want to have your data only available in a specific context. Maybe you have like a secret in your code which you don't want to make available anywhere to be accessed from the current thread or from like other libraries. Maybe you want it to only be available in a certain part of your code. Then you can also use the scoped value and say, for this function, I will set this value, elsewhere it will not be available. And also, if you want to have immutable data, if you don't want to check if somebody else maybe updates your ThreadLocal variables, you can also use scope values, because they can't be like changed, they can only be like overwritten inside of a scope. So to give a quick recap, what have we talked about? First, we have seen about virtual threads, what changed between 1 and Java 25, and we also saw like how you can make your application much faster. Also, we saw that with structured task scopes, you can use them like to their most potential by just using them to run code concurrently. And we then saw also that scoped values should be used when you're using structured task scopes or any like more than one thread per request model, so that you still have access to like your thread local variables. So let's switch over to the questions. Perfect. Are virtual threads and structured concurrency the death of reactive frameworks? Yeah, this is something which I get asked quite often, and I think it's like, in my opinion, currently, if you have like an application running reactive, it's not really necessary that you change it if you always imply that you understand what happens in reactive programming. I think this is like the hardest thing. Like the small examples are always easy to understand, but when they grow and grow even more, then it's really hard to still understand what gets triggered by which part of the code. So I think if you create a new application, I would highly suggest that you are using again the blocking approach, but with virtual threads and structured task scopes. But I wouldn't now just rewrite everything from reactive back to like blocking. You most likely will not have a performance increase because it should be like on par because of the performance. Now, what I need to say is reactive programming was invented back like over 10 years ago for Java because we had the issues with the threads there. So of course it was valuable for the time, but like everything, especially nowadays, is changing really fast. So I think it will be the death like in the future. I don't think somebody would use this anymore for normal stuff. Maybe there are some like niches, but normally I don't think so. How do you see complete solution structured task scopes living side by side? Yeah, what are different use cases? I think it's like the completable, basically structured task scopes and completable futures are a little bit, it's moving. This one. Yeah, so they can, of course, live side by side. You can also have, like, if you want to migrate your application, you can still leave stuff completable futures enabled and one running with virtual threads. You can also enable virtual threads for your asynchronous applications. This will not really hurt. It will maybe create one or two. It will create a little overhead, but this shouldn't really bother you. Can I say that they are answered somehow? Oh, maybe I had to. Okay, let's improvise this. How are virtual threads scheduled? Are all fork tasks first scheduled, or is it supposed to have a virtual thread be scheduled again? Yeah, you can. Yeah, this is something really great question. This is something I show you. What you can do is, yeah, fine. It's nice. What you can do is you can have an additional property in here, which is configuration, and it's configuration like. Have like a special with name here, with thread factory and with timeout. And this with thread factory you can also use to specify a specific kind of thread you want to use, or like have your own like thread pool for your specific scopes. So you can always make sure that inside of a scope you can handle the stuff all yourself. And especially this with name, this looks a little bit, why should you have this? But this is really helpful when you have like a stack trace to see from which scope this thread came from. But this would be, I think, the case where you can handle this. Of course, you can also still, when you have the executor service, you can still use this and configure it like you want. Like if you have your own library, or if you're not using Spring, something else, you can still use the executor service and then configure it like you want. With Spring MVC, do HTTP requests start on worker threads or virtual threads? So if you're enabling the virtual threads the virtual threads property, it will be using virtual threads. So as soon as something enters your system, it will not use the thread pool executor service, but the new virtual thread per task. But of course, it's still currently disabled. So it's not like per default enabled. Does Spring Boot support scope values for internals? Yes, so Spring Boot is like since a really long time, since it's final, it's supporting scoped values to use it, so you can use virtual threads so you don't have to care about this stuff. So for example, you can still use like Spring security as far as I know that you don't have to worry about ThreadLocals internally. Spring Boot will handle that. Of course, in the newer versions, I don't know if they also supported it when it was experimental. The custom joiner has a default branch in which switch is unreachable. Do you think, if it is a mistake to subclass task into incomplete instead of having a custom type? I don't really get what's exactly meant. I will come back to it. Maybe I will get it in the background thread running. And can be passed into fork. Are scopes thread safe and can be passed into the fork call? Asking if it's possible to avoid using concurrent data structure in a joiner based implement subtask collection. I can't really tell. I don't really know if this is. I think they should be like thread safe if the underlying architecture is we are using, like with all the, like if you're using like concurrent collections and so on. But this is something you maybe have to ask the Spring maintainers. Is there a guarantee that two concurrent virtual threads will run in separate real threads, meaning that they won't share the same thread local info? Yes. So if you have virtual threads, this is the cool thing. Like if you're working with threads, and this is maybe something you have seen here. If you're checking here the thread test, and I create a virtual thread, this is still a normal thread. So for you, the change which happened in Java 21 for virtual threads, they changed everything in the JDK to be compliant to virtual threads. So they had like 100,000 changes in their JDK pull request where they merged it. So they made sure that you really can use virtual threads, and you don't have, virtual threads are not like a special kind or a niche thing. They are really just normal threads, just more lightweight. Let's switch back here. What about the tooling? Yeah, so tooling is also interesting. I am not really that deep into how you can use it, like to really do really deep analysis of virtual threads. But what I've heard is that with the recent versions, they really improved also how the virtual threads, especially with Java 25, can be monitored, or you can have information. But I can't really tell you that because I don't really often do these kinds of specific checks of threads, or how the thread dumps are. I'm most likely like creating web applications, CRUD stuff. So maybe also a question for the more core guys. Support with Spring Boot customer joiner. Yes, back to that one. I still don't. Who asked that question? Maybe. Yeah. 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 Okay. Yeah. 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 So for the ones who watch this in recording, question was: should we create a custom subtype of this subtask which can only have a success or failed one? Yes, you of course could do that. You could also just create like an if-else state without using the switch statement, like if this happens or then that, like if you have like something like that. You can also then just one. But of course, yeah, you could create your own custom subtask, but then you would have them to like cast it in here. So of course you could do that, but yeah, maybe it would be, of course, it would be possible. So I have no more time left. I went there like 15 minutes ago here to this. I don't know about this. So, but people are raising their hands. So, yeah. But let me go back here. Yeah.